Children listen. Now, ninth question from first exercise. Let M is a set which has the elements is of the form x, 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 such that x belongs to r minus 0. Here, M is a set which has the elements is of the form x, 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 which is a 2 by 2 matrix, and whose entries are same and one, x, 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 y, 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 e, 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 likewise. Okay, that is same and one. Where the entry x is belongs to r minus 0. That means x belongs to r minus 0 means x is a real number but which is not equal to 0. 0 is excluded. So, see for example, 0, 0, 0, 0 is not possible. Other than that, all the elements are possible. See for example, 1 by 2, 1 by 2, 1 by 2, 1 by 2. Yes, it is possible. 1 by 4x, 1 by 4x, 1 by 4x, 1 by 4x, likewise. So, other than 0, remaining elements are possible. And the complex not possible. Okay, next. Let M is a set which has the elements x, 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 such that x belongs to r minus 0, and let star be the matrix multiplication. Here the operation star is defined as matrix multiplication. Okay, here M is a set and the matrix multiplication is the operation. Listen carefully. Solution where M is a set and the matrix multiplication is the operation. Multiplication. Okay, where star is equal to matrix multiplication. Given M is a set and the multiplication is the matrix multiplication is the operation. That is important. Next, see M is a set and the matrix multiplication is operation. Then determine whether M is closed under star. So first we want to find whether the matrix multiplication is closed and see closed under M on M, that you want to find. That means closed under star is nothing but a binary operation. First we want to identify the star is binary operation or not. That which means matrix multiplication is a binary operation or not. That we want to identify. Okay. Determine whether M is closed under star, which means whether matrix multiplication is closed on M or not. That you want to verify. Okay. Suppose if it is closed, then if so, which means if it is closed, examine the commutative and associative. Yes. See, if it is closed axiom true means, then we want to find commutative axiom and associative axiom. That is commutative property and associative property satisfied by star on M. Okay, where star is equal to matrix multiplication. Don't forget. So M is a set, matrix multiplication is operation. Okay. So matrix multiplication is closed means, then we want to find the commutative axiom and the associative axiom. Okay, it is one part. And see which is the second part. In book, commutative and associative properties one part. And also next part is say that is the same question, but next part also examine the existence of identity. Also examine the existence of identity, existence of inverse properties for the operation star on M. Okay, M is a set and the matrix multiplication is operation. We want to verify closure axiom, commutative axiom. Closure axiom also want to verify. Okay, closure axiom. First closure. If it is closed, then we want to find the commutative axiom, associative axiom, existence of identity and existence of inverse. So totally how many topics you want to find? Yes, there are 5 topics. Closure axiom, commutative axiom, associative axiom, existence of identity and existence of inverse, or identity axiom, inverse axiom. Like that you want to verify. Okay, but solution. Now subdivision 1. Subdivision 1 is closure axiom. Closure axiom. Closure axiom. Listen carefully. Closure axiom. Okay. See, to prove closure axiom, we want to select 2 elements in the given set. Listen, it is one element. See, listen for example, here x is given by the name capital X because matrix is given by capital letter name. Now listen carefully. Let capital X is equal to XXXX. Okay, comma, capital Y is equal to YYYY. That's all. So these 2 elements belongs to M. let x is equal to xx, comma, y is equal to yy belongs to M. Okay, these two elements are belongs to M, such that x comma y belongs to r minus 0. Okay, such that x comma y belongs to r minus 0. First step. Now I want to verify closure axiom. Say, to prove closure axiom, select two elements, that is, capital X is equal to xxxx, capital Y is equal to yy belongs to M, such that x comma y belongs to r minus 0. Now, see, matrix multiplication is an operation. So therefore, see, x into y is equal to, okay, x into y is equal to x into y, that's all. X into y. Okay, what is x matrix? Yes, x matrix is equal to xxxx. Y matrix is equal to yy. Now, just a matrix multiplication. Matrix multiplication means first row into first column. Okay, can you tell me the answer? Yes, first row into first column, first element into first element, x into y, xy. Second element into second element. What is your answer? Yes, plus xy. Okay, listen. First row into first column, first element into first element, x into y, xy. Second element into second element, x into y equal to xy. Over. Now, first row into second column. First row into second column, first element into first element, x into y, xy. Okay, xy. Next, second element into second element, plus xy. Similarly, taking one row and multiplying all the columns. Now, second row into first column, x into y, xy, plus x into y, xy. Next, second row into second column, that is, x into y is equal to xy. Next, x into y is equal to xy. Now, simplification. Yes, xy plus xy. Yes, 2xy. That is 2xy. xy plus xy, 2xy. So, xy plus xy, 2xy. So, xy plus xy, 2xy. Whose left hand side is capital X into capital Y, because matrices given by capital letters name. Okay, the entries are small x, small y, but the matrices are capital X, capital Y. That is important. Okay, now listen. M is a set which has the elements is of the form xxxx, yy. See, it is a 2 by 2 matrix whose entries are same and 1. And this entries not 0. That is important. Okay, here, see 2xy, 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 2xy. All the 4 entries are same and 1. Also, 2xy is not equal to 0 because x is not equal to 0, y is not equal to 0. Therefore, 2xy is not equal to 0. Now, here the condition is, since the condition x is not equal to 0, y is not equal to 0, therefore 2xy is not equal to 0. Here r minus 0 means not equal to 0. Therefore, this matrix is belongs to M. Yes, this matrix is belongs to M. That is, the product xy is belongs to M. Therefore, closure axiom is true. Therefore, closure axiom is true. Closure axiom is true. Okay, closure axiom is true. Now, second one. See, first closure axiom completed. What is second one? Yes, commutative axiom. Commutative axiom. Commutative axiom. Listen carefully. Commutative axiom. Commutative axiom means A star B equal to B star A. Commutative axiom. For example, xy is equal to y. See, x into y equal to y into x. Commutative axiom. Okay. See, first, see, already xy answer is available. Okay. See, already xy answer is available. Now I want to find y into x. Okay. So first, find x into y. Listen carefully. First step, commutative. X into y is equal to x into y. That is, x is equal to xxxx. Y is equal to yy. Okay. Now, which is equal to? What is the product? From closure, say xxx, yy is equal to 2xy, 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 2xy. One can write it directly because already we find the answer. So, xxx, yy is equal to 2xy, 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 2xy. So, which is equal to 2xy, 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 2xy. Okay. Now, which is equal to this xy is equal to yx. Okay, xy is equal to yx. We can rewrite like that. Because say x into y is equal to y into x in the set of all real numbers. Okay. X into y is equal to y into x in the set of all real numbers. That is, multiplication is commutative in the set of all real numbers. Okay. This entries itself we want to make the commutative. Okay. Which is equal to here 2 fixed. X into y is equal to y into x. And similarly, x into y equal to y into x. And say 2yx. 2yx. Okay. Now listen, which is equal to. Now we have the technique. Listen, already here it is a reverse answer. Suppose your answer x into y means first element x, x. Second element y, so y. Using that idea, now first element y means y. Second element x means the matrix is x. Like that I can write. Listen, which is equal to y into x. Okay? Oh. Now, listen carefully, the left hand side is xy, that is important. Okay, it is going on continuation. Now, that is xy is equal to, listen carefully, here there is no place, so I want to write here, that is x into y. X into y is equal to, here y is equal to capital Y. Okay, x is equal to capital X, that's all. So, initially we taken xy. And finally we proved y into x. So remember, how many steps counted? 1, 2, 3, 4, 5 steps. Okay, 5 steps totally. This left hand side only, it is enough to write 1 step. Okay, one time it is enough to write. Now xy is equal to, taking xy, finally we proved is equal to yx. Therefore, matrix multiplication is commutative. Therefore, commutative axiom is true. Therefore, commutative axiom is true. Commutative axiom is true. Okay. Children, listen. Now, say closure axiom, commutative axiom completed. Okay. Now, third subdivision, associative axiom. Listen carefully. It is very easy. So, third subdivision, associative axiom. Associative axiom. Okay? Okay. See, for associative axiom, we want to select how many elements? Yes, 3 elements. Can you tell me the associative axiom formula? Yes. A star, B star C equal to A star B star C. Okay. Now, here we are taken the 3 elements are capital X, capital Y, capital Z. So these 3 are the matrices of same order 2 by 2 and where the entries are same and 1. That is capital X equal to XXX, capital Y equal to YYY, capital Z equal to EZ. Okay. Now I want to take LHS of the associative. Okay, for XYZ means, can you tell me the associative axiom? Yes, X into YZ equal to XY into EZ. That we want to prove. Okay. Now listen, first X into Y. See, X into YZ, which is equal to X into YZ. Okay. X into YZ is equal to capital X, capital Y, capital Z. That is very important. Okay. So the matrices are given by the name capital. These are all capital letters. Okay. Now which is equal to, listen, say that is X matrix into square bracket open. Okay. Because here X is outside, Y and Z inside the bracket. So that is why X matrix into bracket open into Y matrix into Z matrix complete the square bracket. That's all. Now listen, it is of the form X into YZ, where YZ are in the bracket. Okay. Now what is X? Yes, X, where X matrix is equal to small x. Okay. Y matrix is equal to, yes, small y. Okay, Z matrix, capital Z matrix is equal to, yes, small z. That's all. Okay, which is equal to, here outer XXX fixed. Listen, X fixed. Now, first we complete the bracket answer. Can you tell me what is bracket answer? Yes, good. See, from closure axiom, we know that, see, for example, X into Y is equal to 2XY. So every time we can use closure axiom technique. That is, here y into z equal to, yes, 2yz. So your answer is 2yz, 2yz. Okay, next yourself. Yes, very good. 2yz, 2yz. That's it. So listen, y into z is equal to 2yz. Now we want to find these two product. Okay, which is equal to. Now can you tell me the answer? Yes. Because listen, x into y is equal to 2xy, 2xy, 2xy. Y into z equal to 2yz, 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 2yz. Similarly, now say the technique is y into z means we want to say y into z, yz, we want to write extra one too. Say, so this answer already we proved from closure. Okay, from closure axiom. Now we want to use directly. Now say x into 2yz equal to 2yz, sorry, 2xyz. X into 2yz equal to 2xyz. But extra 1 2 we want to multiply. That means, so 2 2's are 4xyz. So 4xyz, yes, good. 4xyz, 4xyz, next, yes, 4xyz. 4xyz, don't forget, 4xyz, 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 4xyz. Okay, bracket complete. Now let it be the first equation. Okay, whose left hand side is x into yz. Okay, so x into yz completed. Now say here last two in the bracket. Now we want to write first two in the bracket. Now xy into z is equal to. Okay, now xy into z equal to. First complete the bracket answer. Listen, here for xy there is a moon bracket. So that is why open square bracket. Open square bracket, say x matrix into y matrix, complete the bracket. Okay, because xy inside the bracket, so that is why for xy square bracket. So x into y bracket. And z is outside. So into z. That's all. Okay, now fill up. What is first one? Yes, x matrix. That is xxx. What is second? Y matrix. Small y, small y, small y. And what is outside? Yes, which is small z, small z, small z, small z, which is z matrix. Completed. Now yourself, start. Yes, because listen, first you complete the bracket answer. X into y is equal to 2xy, 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 2xy. From closure axiom. Already we find out this answer in closure axiom. Okay, now we can use it directly from closure axiom. Now which is equal to bracket. Okay, x into y is equal to xy. But we want to multiply 2 from closure axiom. Okay, so 2xy, next, yes, 2xy, 2xy, complete. Into z matrix, fix it, z. Now, which is equal to, yes, very good. Now, 2xy into z equal to 2xyz, but extra want to multiply 2 from closure axiom. So 2 2's are 4xyz. So your answer is 4xyz, 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 4xyz. Okay, and of course left hand side is xy into z, which is equation number 2. Okay, now from 1 and 2. From 1 and 2, listen, by individual inspection, 4xyz, 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 4xyz. So RHS are equal, therefore LHS are equal. From 1 and 2 it is clear that, x into y into z equal to xy into z. Okay, from 1 and 2 it is clear that, from 1 and 2. Listen carefully, from 1 and 2. From 1 and 2. From 1 and 2 it is clear that, say left hand side, x into yz is equal to xy into z. And it is true for every x, y, z belongs to M, because the given set is M. It is true for every x, y, z belongs to M. Children, listen. Now we completed closure axiom, commutative axiom, and associative axiom completed. Okay, what is fourth one? Yes, that is identity axiom. Okay, subdivision 4, identity axiom. Identity axiom. Here we want to find the identity element. Okay, so we want to find a identity element. For that, let capital E is equal to, let capital E be the identity element. Okay, let capital E matrix be the identity element. Let capital E is equal to small e, small e, small e, small e. So because the set is, M is a set which has the elements is of the form x, 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 y, 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 z, 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 e, 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 like that. That is, which is a 2 by 2 matrix, all the entries are same and one. So that is a given condition. Because of the condition, we are selecting like this. Okay. Let capital E is equal to small e, small e, small e, small e belongs to M. Say, be the identity element of M. Okay. Be the identity. Be the identity of M. Okay. This is the first line. Again, let capital E equal to small e, small e, small e be the identity element of M. Okay. Now, let any one element is capital X. Okay. Let any one element is capital X. Now, by the definition of identity, that is important. By the definition of identity, listen carefully. By the definition of identity, let capital X be any one matrix and E is the identity matrix. Then by the definition of identity, capital X into E is equal to capital X into E is equal to capital E into X is equal to X. Because, can you tell me what is the definition of identity? Yes. A star E is equal to E star A is equal to A. That is, identity topic gives the same element answer. So now, by using definition of identity, we have X into E is equal to, okay, listen carefully, X into E is equal to E into X is equal to X. And by forgetting center, X into E is equal to X. E into X equal to X. So that is identity. X into E equal to E into X is equal to X is the definition of identity. We are considering first and last. That is, X into E is equal to X. That's all. Okay, now just a substitution. What is X? Very good. That is, listen, X matrix into E matrix, which is equal to X matrix. That's all. Okay, can you tell me the next step? Yes, where X matrix is equal to small x, small x, small x. E matrix is equal to small e, small e, small e. And X matrix is equal to small x, small x, small x, small x. That's all. Okay. Now, what is the product of left hand side? Yes. See, for example, X into Y is equal to 2xy. Likewise, X into E is equal to 2xe. That is 2xe, 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 2xe. Complete the bracket. Which is equal to x. Okay? Now, next step yourself. Very good. If the two matrices are said to be equal, then their corresponding elements are equal. Okay? Then their corresponding elements are equal. Which means the first element is equal to the first element. Okay? If the two matrices are said to be equal, then their corresponding elements are equal. So first element equal to first element, second element equal to second element, fourth element equal to fourth element, third element equal to third element, and the fourth element equal to fourth element. Likewise, corresponding elements are equal. Okay, now for our convenience here, all the four elements are equal. So here, first element equal to first element, we get 2xe is equal to x. Okay, here we are taking E is the identity element. So I want to find this E value. So that is why E is equal to x by 2x. So this 2x goes to right, becomes divided. Okay, E is equal to x by 2x. This 2x goes to right. Now using pencil or case, one time of x, cancel. Therefore E is equal to 1 by 2. Okay, E is equal to 1 by 2. So which is equal to 1 by 2. What is 1 by 2? E equal to 1 by 2. That is important. Now remember, this 1 by 2 is not belongs to M. See, that is matrices belongs to M. That is idea. And also, we need the identity element in the form of matrix. So, substitute this E value in capital E. Okay. So, therefore, capital E is equal to. Therefore, the identity element capital E is equal to. Therefore, the identity element capital E equal to. Substitute small e is equal to. Small e is equal to 1 by 2. Substituting small e, why not? We can write here also. That is small e is equal to 1 by 2. We derived the answer. So, which is the required answer. Okay. Small e is equal to 1 by 2. Substitute small e equal to 1 by 2 here. Therefore, the identity element is capital E is equal to 1 by 2, 1 by 2, 1 by 2, 1 by 2. That's all. Okay. Therefore, the identity element is. Therefore, the identity element. Therefore, the identity element is capital E is equal to, substitute this 1 by 2 in capital E. Okay, that is very important. Substitute 1 by 2 in the matrix because we need the answer in matrix form. That is important. E equal to 1 by 2 is not answer. So, substitute E value here, that is in capital E matrix. So, that is answer because we need the answer in matrix form. Therefore, capital E is equal to 1 by 2, 1 by 2, 1 by 2, 1 by 2. Now, this here all the 4 entries are same and well. Therefore, this matrix is belongs to M. Okay. And don't write 1 by 2 belongs to M. This matrix only belongs to M. And the final answer I need in the matrix form. Don't stop up to E equal to 1 by 2. And also, listen, here, say 1 time of x, 1 time of x. So 1 by E is equal to 1 by 2. Okay. Here remember this denominator, that is x. Denominator x is not equal to 0. Because suppose x is equal to 0 means you get a 0 by 0. 0 by 0 is indeterminate form. Okay. So that is why where x is not equal to 0. That is important. Or x belongs to r minus 0. That is x is not equal to 0. Also correct. Which is the identity element is ready. Children listen. Now already we completed closure axiom, commutative axiom, associative axiom and identity axiom. What is the fifth one? Can you tell me? Yes. Which is fifth subdivision is inverse axiom. Inverse axiom. Okay. Inverse axiom or inverse property or existence of inverse. All are same keywords. No problem. Okay. Inverse axiom. Here. Listen, identity axiom gives the same element answer. That is, x into E is equal to x. Now, inverse topic gives identity answer. That is important. Inverse topic gives identity answer. So that is why, now, let capital Y is equal to small y, small y, small y, small y be the identity of x. Listen carefully. Let capital Y is equal to small y, small y, small y, small y be the inverse of x. Be the inverse of capital X. That's all. Let capital Y equal to small y, small y, small y, small y be the inverse of capital X equal to small x, small x, small x, small x. That is, let Y be the inverse of X. So that is the statement. Now, by the definition of inverse, okay, by the definition of inverse, x into y is equal to E. See, x into y is equal to y into x is equal to E. That is the definition of inverse. By the definition of inverse, x into y is equal to y into x is equal to E. Okay. Now, forgetting center, let us consider first and last. That is, x into y is equal to E. Okay. Now listen, by the definition of inverse, x into y is equal to E. But middle we have one more step. That is, x into y is equal to y into x is equal to E. We are forgetting center, taking first and last. Okay. What is x? Can you tell me? Yes, very good. See, x matrix into y matrix, x matrix into y matrix, which is equal to E matrix. Okay. What is x matrix? Yes, x matrix is equal to small x, small x, small x, small x. Y matrix is equal to small y, small y, small y, which is equal to, that is where capital E we are taken as identity axiom. That is identity element. What is, see, just before topic, what is identity element? Yes, the identity element capital E equal to 1 by 2, 1 by 2, 1 by 2, 1 by 2. Now I want to substitute this capital E matrix here. Okay, so capital E matrix is equal to 1 by 2, 1 by 2, 1 by 2, 1 by 2. Really capital E equal to small e, small e, small e, small e. And we are substituting small e is equal to 1 by 2, 1 by 2, 1 by 2, 1 by 2. So for capital E, that is for identity capital E, we want to use this answer here. Okay, now this last line no need, because we substituted, we can refer. This line now no need. Okay, because that is the before answer. Now it is very simple. What is left side? Yes, very good. X into y equal to xy. But from closer axiom, already we find out the answer is 2xy because of the multiplication. Now listen, your answer is, that is 2xy, 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 2xy is equal to 1 by 2 fixed. Listen, 1 by 2, 1 by 2, 1 by 2, which is fixed. Okay? Now, again, listen, left side one matrix, right side one matrix, middle equal. If the two matrices are said to be equal, then their corresponding elements are equal. Okay? So, that is the first element equal to first element. Okay? Why not? Second element equal to second element also gives the same idea because all the entries are same at one. Now, equating first one equal to first one, we get 2xy is equal to 1 by 2. Okay? Now, listen, we have taken y is an inverse element. So, that is why I want to find y value. Okay? Y only left side, remaining right side. That is, tell me what is y is equal to? Yes, this 2x goes to right, becomes divided. Divide means that is already denominator 2. So 2 to are 4x. So which is y is equal to 1 by 4x. That's all. Y is equal to 1 by 4x. Now listen, y equal to 1 by 4x. This 1 by 4x is not belongs to m. Don't write like that. But we have the rougher case. Here the denominator x is not equal to 0. Okay, x is not equal to 0. That is important. X is not equal to 0. Okay, y is equal to 1 by 4x. Here, whether can tell me whether y is equal to 1 by 4x itself answer? Yes, no. See, because we need the answer in matrix form. We need the answer in matrix form. So, substitute y is equal to 1 by 4x. Substitute y is equal to 1 by 4x in matrix, that is in inverse matrix. So which is not answer because we need the answer in matrix form. Therefore, capital Y is equal to, listen carefully, capital Y is equal to, substitute small y is equal to 1 by 4x. So capital Y is equal to 1 by 4x, 1 by 4x, 1 by 4x, 1 by 4x. Okay, which is belongs to M because 2 by 2 matrix of same entries belongs to M. So that is why. Therefore, inverse of x, that is y is equal to, capital Y equal to 1 by 4x, 1 by 4x, 1 by 4x, 1 by 4x belongs to M is an inverse of x. Okay, is an inverse of x. Therefore, capital Y is equal to 1 by 4x. Listen, capital Y is equal to 1 by 4x, 1 by 4x, 1 by 4x, 1 by 4x, okay, belongs to M is an inverse of x. Is an inverse of x, is an inverse of capital X. That's all. Therefore, inverse axiom is true. Okay. All the 5 topics completed.